All right, let's get started with Unit 1, Day 2. Absolute value. Absolute value means how far away is a number from zero on the number line. Extraneous solution means that, well, we solved, we got an answer, but it doesn't work. We'll get to that momentarily. Whenever you have an absolute value equation, you want to make sure that the absolute value is isolated, which this one is. And you want to create two problems. The first one's going to look very similar to the original. I just dropped the absolute value bars. The other one, almost the same, just make it negative. And then you solve for x. But there's nothing to solve for here. We're done. X equals 8, x equals negative 8. Now what you're supposed to do is plug them in to see if it's true. We plugged in 8 for x. Is the absolute value of 8 8? Yes, it is. If we plugged in negative 8, is the absolute value of negative 8 positive 8? Yes, it is. Remember, negative 8 on a number line, let's say negative 8 is here, and here's 0. It's still 8 spaces away from 0. So that's why absolute values need to always be positive. For example 2, you could create two equations, x equals 0, x equals negative 0, but that's not really a thing. So here, your only answer is x equals 0. For example 3, you might be tempted to say, oh, let's set up two equations, x equals negative 2 and x equals 2. Let's do some thinking here. What absolute value will produce a negative result? There's not one. Your absolute values will never be negative. So no solution, or you can do that. No solution. Example 4. Now we have an absolute value equation that's going to require a little bit more work. The absolute value here is isolated. So let's create two problems. I recommend doing that first so that you are reminded that you might have two answers. Now we want this time it equal to be negative 6. Notice what stayed the same. Notice what changed. Now let's solve this one. Add 3. X equals 9. That's one possible solution. Okay, let's add 3. Add 3. X equals negative 3. Now you might be thinking to yourself, okay, well, our only possible answer is 9, because remember, we can't have a negative. Wrong. We can have a negative. Just when you plug it in, it has to make sense. It has to be a true statement. If we plugged in 9 right here, 9 minus 3 is 6. And the absolute value of 6 is 6. If we took negative 3 and plugged it in here, negative 3 minus 3 is negative 6. And the absolute value of negative 6 is positive 6. Therefore, both of these are the solution. Example 5. Now, before we can start creating two equations, we have to make sure the absolute value is isolated. This is an example of it not being isolated. We have a negative 1 that we need to get rid of. We have a positive 3 that we need to get rid of. And you want to do your order of operations backwards in order to do that. Is there anything we can add or subtract away from our absolute value first? There is. Let's subtract this 3 from both sides. Okay, now don't distribute that negative. Let's divide both sides by negative 1. Now the absolute value is isolated. Now create your two problems. Here, let's add 4. Both sides. Divide both sides by 2. X equals 6. And if you were to plug, actually, I'll get to that in just 1 second. And divide away the 2. x equals -2. Now, when you go to check these, don't plug it in to the original problem. Plug it in to the isolated absolute value. And if you plugged both of these in, they would both work. So these are our solutions. Example 6. Oh my goodness. What do you notice about this one that's different from all the other ones? We have an x on the right side of the equal sign. Approach with caution. Now, the absolute value is isolated, so we can create our two problems. There's the first one. Now let's do the second. There's the second. Let's start solving. Let's divide away that 2. 5 is equal to x. Let's solve this one over here. And x equals -1. Now, you remember me telling you at the beginning, approach these with caution? Truth be told, you're supposed to check every single solution you get in math, but we rarely do because most of the time they're solutions. If you have a scenario like this, you want to check them. I'm going to show you a little bit of a shortcut. Let's just cover that part up. Let's pretend it's just 6x for now. What happens if we substitute +5 here? Well, 6 times 5 is 30, +30. It's possible that when we substitute 5 here, we're going to get the absolute value of 30 or -30, and we would get the right answer. Okay? So here's what I did. Take 5, plug it in there. 6 times 5 is 30. That's possible. And by the way, that is one of our answers. X is going to be 5 here. Okay, now forget about this part for now. Take -1 and plug it in here. What is 6 times -1? -6. Will an absolute value ever produce a negative result? No, it will not. This is your first example of an extraneous solution. So how does this come in handy? Well, think about your next test. If you were to have to solve and you put the answers are 5 and -1, you're wrong. The only answer is 5. But what if it asked you to identify the extraneous solution? Well, then in that case, your answer is not 5. Your answer would be -1. Remember that. Okay, let's start working on example 7. Notice this has an x on the right side of the equal sign. Approach with caution. Here, our absolute value is isolated, so we can go ahead and begin creating our two problems. Problem 1. Now look at how we need to create problem 2. When you have more than 2 terms, make sure you write it like this. All right, let's start simplifying this one here. That's going to give us -x. I'm going to add 2, bring it over here with the -10. -10 plus 2, -8. Divide the negative away. X equals 8. Potentially an answer. All right, let's start simplifying this one. Distribute. Distribute. Now let's combine like terms. Add 2, bring it over here with the +10. 10 plus 2 is 12. Divide the 3, x equals 4. All right, now we want to check them. Let's start by plugging them in over here with this x. If you took 8 and plugged it in here, let me simplify that. 2 times 8 is 16. And 16 minus 10 is 6. That's a possible. The answer is positive. And I guarantee if you plugged it in here, you would see that it works. X equals 8. Let's take 4 and now substitute it here. 2 times 4 is 8. And 8 minus 10 is negative 2. So if we substitute 4, what it's saying is our result's going to be negative. And that is just not the case. So 8 is your only solution. 4 is the extraneous solution. Example 8. Let's work on this one. Okay, with example 8, the absolute value is not isolated. So we're first going to need to subtract 9 from both sides. Now stop there. We have isolated the absolute value. What this is saying is that our absolute value is going to produce an answer that's negative. That's never going to happen. So stop there. No solution. Example 9, the absolute value is isolated. So let's drop the absolute value bars, keep what's inside. And create 2 problems. Let's start solving this one. How about we add 3 first? Divide away the negative 2. M equals negative 14. Let's start working on the other one here. Let's add 3 to both sides. Let's now divide both sides by negative 2. M equals positive 11. Now you would then want to take these solutions individually, plug them in there for M, and see if they produce a result where the absolute value is 25. And both of these would work. With this example, the absolute value is not isolated. We need to free up the denominator. So to get rid of that 4, multiply both sides by 4. These cancel, leaving you with the numerator. And 2 times 4 is 8. Now that the absolute value is isolated, let's create our 2 problems. Let's start with this one. Add 1 to both sides. Divide away the negative 3. All right, x equals negative 3. Took that, plugged it in here, you would get the absolute value of 8. So that is a solution. Let's solve this one now. Negative 8 plus 1, negative 7. X equals 7 over 3. It's a fraction, but it still would work. If we took 7 over 3 and substituted it there, you would see that it also equates to the absolute value of 8. Both of those are the solution. Example 11, very similar to the example we just got finished doing, I think. Let me see. Yeah, very, very similar. To start, you need to multiply both sides of this equation by 3. And if you did that, We're left with our numerator in 4 times 30 is 12. Now that the absolute value has been isolated, create 2 problems. There's our first one. And the second. Let's solve. Start by subtracting 8 here. Divide away that 2. There's our first solution. Subtract away the 8. Divide away the 2. X equals -10. Both of those solutions, if you plug them in and solve, would work. And now example 12. The absolute value is isolated, so create your 2 problems. There's the first one. There's the second one. Let's start solving. I'm going to add 3x to both sides with this one. Now let's divide away that 9. Now over here, let's add 3x to both sides. Divide both sides by -3. -9 equals x. Now, hopefully you caught before we began this one, or begun, I don't know which one's right, whatever. But there's an x right there. Approach these with caution. So let's just substitute here. 3, plug it in. 6 times 3 is 18. Positive. So that one's going to be a solution. -9 times 6. -54. Negative. I don't think so. We are never going to get a negative result from an absolute value. This one is extraneous. Now we have some information to write down. What do you notice about all the equations with extraneous solutions? When your absolute value is isolated, there's a variable on the non-absolute value side. How can you quickly check for extraneous solutions without having to plug your variable into the entire equation? Well, after isolated, plug your answers into the non-absolute value side. If that result is negative, then that solution is extraneous rather than a solution. Good job, everybody.